Hello viewers, welcome back to the course on matrix computation and its application. So, in the previous lecture we have started with one relation, that how we can find out the left hand null space with the help of the matrix P. So, we will continue with that one. So, today we are going to write one definition about left hand null space. So, left hand null space means we are talking about n transformation. So, it says that if I have a matrix A m cross n with rank is equal to R and R, and if P A is equal to U, where U is an echelon form of A. So, we are talking about echelon form is row echelon form. Then the last m minus r rows in the matrix P span the left hand null space of matrix A. And so, now here we are writing P is written as P1 and P2. So, from here we have that the null space of A transpose is equal to range of the matrix P2 transpose. So, this is my matrix P that is defined here, and the last m minus row. So, from here you can write that if the rank is row R, so it is this mat is m cross R, and this is the remaining one m minus R cross R. Okay, so this is the dimension of the matrix. Maybe I can just write specifically. So, P1, so the dimension of will be m cross R, P2 dimension will be m minus R cross R, or maybe it can be anything. So, I can write just this one. That is it. So, these things we have also discussed in the previous example. So, this is the some observation about the left hand null space. Now, the next thing we want to discuss about 0 null space. So, in the 0 null space we say that if A is a m cross n matrix, then first one is null space of A will be 0, only the 0 element, if and only if the rank of A will be n. Because this is the matrix A m cross n matrix is from Rn to Rm. So, if the rank of matrix A is equal to n, so that is equal to the number of variables, then the null space will be only containing the only 0 element. And why it is containing 0 element? Because the 0 is always the solution of the homogeneous system A x equal to 0. And the second one is null space of left null space will contain only 0 element if and only if the rank of A transpose is equal to m. So, that is the observation we are going to have, and this one we know that. So, that we have seen that the matrix A m cross n is moving from n Rn to Rm, and also we has the subspaces, that is 4 subspaces we are going to have. So, this is my Rn and this is my Rm, and we have a transformation that is A, and we know that range space of A transformation and n of A, and this is R of A and this is n A transpose. And we also know that dimension of R range space of A is same as dimension of A transpose, and that is equal to rank. Okay, so in this case we know this one. Now, as it is given that rank, suppose I will take the rank of this one. Now, just I want to give the flavor of the first one. So, first one says that if and only if, so let I say that the rank of matrix A space rank of matrix A is equal to n. Now, it is coming from here the Rn. So, x belongs to Rn, and now suppose I have Ax and rank of n is this one. So, from here you will see that the range space of this has the dimension that is equal to rank, and that is n. Now, from here, now these subspaces are coming from the Rn, but we found that the dimension of R A transpose is n, and that is also same as dimension of R A T, sorry, R A, this one. So, from here you will know that the dimension of null space will be 0, because it is already coming from here and it is completely n. So, the dimension of the other space subspace in this is coming 0. Actually, these things we can just do with the help of the system A x is equal to 0, or maybe A x equal to some element b. Now, my A is basically m cross n, my x is coming n cross 1 and B is coming m cross 1. Now, from here, if rank of matrix A, that is coming n, then we know that we are going to have unique solution. So, in this case, if I take this one, so we are going to have a unique solution, and we are going to have unique solution, then I am going to have my Ax is equal to 0 is going to have only trivial solution, and if a trivial solution means my x will be 0. So, that shows that the null space of A will contain only 0 element. Okay, so, this also can be taken in this way, and these things I have just told you because when in the later on we are going to show one theorem that is about the rank and nullity theorem. So, in that theorem we will find some relation related to this one, but now as for now whatever we have written here, that if the null space is 0 if and only if rank of the matrix is equal to n, the number of variables. So, just keep in mind, and later on we will prove this one based on the some other theory. So, these things you can familiar with. So, that is why I have taken this thing here, that this thing is we have already done. So, from there we can make the conclusion that if the rank of the matrix is equal to the number of variable, then the null space, corresponding null space is going to have a only 0 element. So, now based on this one I am going to take a quick example from for a given matrix A. So, this is the example I am going to take 1 2 2 3 1, and this is 2 4 4 6 2 3 6 6 9 6 1 2 4 5 3. So, 4 cross 5, this is a 4 cross 5 map. Now, in this case it is A is 4 cross 5, it means it is moving from R5 to R4, and also we know that the rank of matrix A is always less than equal to minimum of Mn, and that is in this case it is 4. So, the rank of the matrix is going to be 4, less than equal to 4. Now, in this case suppose the rank of the matrix becomes 4, it means all the 4 rows will be effective to make the range space, and then we can also see that the null space will be corresponding null space will contain only 0 element. So, these things we can find out. Now, this is my matrix. So, I want using this matrix I want to find all the 4 subspaces. I want to check whether this theorem or this observation is satisfying there, and also I am going to use this one. Now, so for this one I take the augmented matrix, So, this is my augmented matrix A, the identity matrix I. So, from here this can be written as 3 1 2 4 6 2 4 4 6 2 3 6 6 9 6 1 2 4 5 3, and now it has a 4. So, I will write the corresponding identity matrix of order 4. So, I am writing the identity matrix order 4. Okay, so that we can choose from here. Now, I will transform this to the row echelon form to U. So, I will apply the formula. So, now from here I will write minus 2 R1 plus R2 minus 3 R1 plus R3 and minus R1 plus R4. So, directly I can write. So, it is 1 2 2 3 1 1 0 0 0. Now, it will be 0 0 0. So, minus 2. So, that will be also 0, and this is also 0, this is 0, and this is also 0. So, this is coming 0 here. Now, from here it is 0 because minus 3 I am multiplying. So, 0 minus 6 0. So, that is also 0, and minus 3 minus 9 0. So, minus 3 plus 6 it will be 3, and the corresponding 0. So, I am writing here minus 1 plus 0 minus 2, this is also 0, minus 2. So, it will be 2 and 2 2, and from here this is my 1 0 0. So, I am just multiplying here with minus 2 and adding here. So, it will be minus 2 1 0 0 minus 3. So, it will be minus 3 0 1 0, and this is minus 1 and adding into R4. So, it is minus 1 0 0 1. Now, from here I just swap the R2 with R4. So, it become 1 2 2 3 1 1 0 0 0 0 0 2 2 2, and that is coming minus 1 0 0 1. Okay, it is coming 0 0 0 0 3, it is minus 3 0 1 0, and the last I will get minus 2 1 0 0. So, this I am getting. Now, so from here you can check that this is my echelon form. So, that is my row echelon form, and this is, I can say from here that this is my P. Now, based on this one, so my P, if you see from here, so the rank of the matrix A in this case is coming 3, and the number of variables. So, if you see from here, the n is 5, so rank is 3, so it is less than 5. So, we can check from here that in this case the null space is not going to have only 0 element, it is going to have the element more than 1. So, its dimension we have to find out. So, this is my rank of the matrix 3. Now, if you see from here P, So, P is coming basically 1 0 0 0 minus 1 0 0 1 minus 3 0 1 0 and minus 2 1 0 0. So, from here you can check that rank is 3. So, this first 3 rows, that makes it P1. So, its dimension, if you see, its dimension will be 3 cross 4, okay. And this last row corresponding to the 0 row. So, because this is going to be the corresponding to the 0 row, so this will be treated as P2 and its dimension is 1 cross 4 and the rank was 3. So, that is why we generally do not write the dimensions here, because it everything depends. So, from here I get the value of P. Now, from here, so very quickly I can write all the subspaces. So, from here one thing is true, that since rank of the matrix A is 3, that is not equal to number of variables, that is number of variables, that is 5. So, from here that null space of A is not going to have only 0 element. So, this is we have taken from here. Also, rank, since the rank of A is 3, which implies that the range space of A and A transform is going to have dimension 3. Okay, so, this one we can write down directly. Now, from here very quickly I can write that the range space of A is a span of the vectors. So, I will take this matrix. So, in this case this is my pivot element, this is my pivot and this is my pivot. So, these are the 3 pivot elements and this is non-basic columns. It means x2 and x4. So, from here you can write down that first, third and fifth. So, it is the range space of A is made up of the basic columns. So, basic column is basically 1, 2, 3, 1, 2, 4, 6, 4, because I am taking first, third and fifth. First, third and fifth is 1, 2, 6, 3. So, this is a span by this one, and you can check that these are the also Li, linearly independent. From here you can check, it contains only 1 0 0, another one is contain 2 2 0 0 and third one contains 1 2 3 0. So, these are linearly independent. I am writing the corresponding columns here. So, it is 1 2 3 1, 2 4 6 2, 2 4 6 4 and 1 2 6 9, 1 2 6 3. So, this one we have written here, and from here, so this is okay. Now, I can write the range space A transpose. Now, from here you can check that we have also taking the swap of the matrix, and then I got this 3 rows from first 3 rows we have taken from here. So, in this case you can check that this row has been swapped with this row, because I have taken R2 to R4. So, R2 to R4 we have taken, and this became the 0. So, from here you can check that range space A transform is spanned by the rows of A corresponding to non-zero rows of U. So, corresponding to non-zero rows of U. So, now from here you can, so this is basically this row I am talking about. So, from here I just have to leave my second row. So, from here you can check that this is spanned by the element 1, 2, 2, 3, 1. I am just writing in the form of columns, or maybe you can also write as a row vector. So, span by 1, 2, 2, 3, 1, and second one is I am leaving this one. So, it will be 3, 6, 6, 9, 6, and 1, 2, 4, 5, 3. So, these are the corresponding vectors, the rows I have taken, because this is the 0 rows, but it was coming at the second place. So, second place row is this one. So, that we have taken this one. So, now from here, so this is linearly independent vector. You can check that this is a linearly independent vector I have taken, and from here I know that the dimension is 3. So, it is equal to the rank. So, now from here I am able to find RA and RA transpose. Now, from here quickly I can find my null space N A. So, N A is basically all the x such that A x is equal to 0, and this one we can find from U x is equal to 0. Now, U x is equal to 0, so in this example that is why we are taking this one, because we are swapped the row also. Now, I am going to take the corresponding non-zero rows. So, from here you will get the first row. So, we are getting from here x1 plus 2x2 plus 2x3, 3x4 plus x5 equal to 0, because here the x is coming from R5, because it is transformation from R5 to R4, and then from the second non-zero rows it is 2, 2, 2. So, I can write from here it is 2x3, 2x4, 2x5 equal to 0, and then from the third row it is 3x5 equal to 0. So, this one we can write. Now, from here that gives me that x5 is always going to be 0. So, once I get the x5 is equal to 0, now here the non-basic columns are only x2 corresponding to x2 and x4. So, I can write from here that my so I am taking x2 and x4. So, I can write from here so x5 is 0, I can write from here x3 is equal to minus 2 by 3 x 4, and from here I can write my x 5 is 0. So, this part becomes 0. Now, from here I can write my x 1 is equal to minus 2 x 2 and then minus 2 x 3 and minus 3 x 4, and from here I can substitute the value of x 3 here. So, that gives me, I can write my x 1 is equal to minus 2 x 2 minus 2. So, x 3 is basically minus 2 by 3 x 4 minus 3 x 4, and that becoming, so it is minus 2 x 2, it became 4 by 3 because it is 4 by 3 and minus 3. So, it is 4 by 3 minus 3 x 4, and that gives me minus 2 x 2. So, it is 4 minus 9. So, it is minus 5 by 3 x 4. So, based on this one, now I can write my null space. So, it corresponding to the x such that a x is equal to 0. So, x is basically x 1, x 2, x 3, x 4, x 5, and that is coming. So, my x 1 is, I have written, so this is my x 1. So, it is minus 2 x 2 minus 5 by 3 x 4. Then x 2 is x 2, x 3 is minus 2 by 3 x 4, x 4 is x 4 and x 5 is 0. And from here I can write my x 2 as minus 2, 1, 0, 0, 0, just the linear combination, and plus x 4 is minus 5 by 3, 0, minus 2 by 3, 1, 0. So, from here you can see that the null space is spanned by two vectors, and these are linearly independent also. You can check with this one. So, the nullity in this case is 2, and you can also verify from here that the dimension, the rank was 3 in this case, and from here it was the R 5. So, nullity is 2, rank is 3, and from here you can say that it is 2 plus 3 is 5. Now, this is I have written. Now, null space of A transpose, we can write range space of P to T. So, in this case I want to write directly from here that, so this is, so P2 is this one minus 2 1 0 0. So, this is basically we are writing corresponding to the 0 row. So, minus 2 1 0 0. So, range space of the vector minus 2 1 0 0, and what is this? So, it will be equal to minus 2 1 0 0. So, it is 4 cross 1 into x. So, I can write from here that null space of A transpose is spanned by minus 2 1 0 0. So, this is basically we are writing directly from here. So, now from here null space of A transpose is this one, and its dimension is also dimension of N A transpose is 1. So, the dimension is 1 here, and I know that the rank of A is 3. So, range space of A, that I know the dimension is 3. So, it is 3 and plus 1 4. Now, it is coming from R 5 to R 4. So, from here you can check that it is going from R 4 to 4. So, range space of this 3 dimension, N A is 2 dimension. So, it becomes 5 in this case, and it is 3 plus 1 4. So, you can check from here that in this case I can check, we can check that the rank plus nullity, it means I am taking the dimension of range space of A transpose plus dimension of N A, that is equal to 5, equal to the dimension of R 5, and dimension of R A plus dimension of N A transpose, that is also 3 plus 1, that is equal to 4, and that is equal to the dimension of R 4, because this map was going from R 5 to R 4. So, we will make some conclusion based on this one. So, let me stop here today. So, in the today lecture we have discussed two very important relation or topic, that how we can write down all the 4 subspaces related to the matrix after converting the matrix into the row echelon form. And then also we have shown that if the rank of the given matrix is equal to the number of variables, then definitely the null space corresponding to that is going to be only 0 null space or maybe trivial null space. So, in the next lecture we will continue with this concept. So, thanks for watching, thanks very much.